Okay, so for 7.2, we are going to multiply polynomials. In 7.1, we added and subtracted them. Today, we're going to multiply them. We will not be dividing them in Algebra 1, though, so this is it after this. Okay, you kind of already know how to multiply polynomials because in 6th grade, you learned something like this. Let's say x minus 4, okay? So what you maybe didn't realize at the time, and in 6th grade, they maybe didn't call that a monomial, and they didn't call this a binomial, but we know that binomials have 2 terms, monomials have 1, trinomials have 3, and so on. So really, when you are asked to distribute a 3, you may not have known it, but you are multiplying a monomial times a binomial. And by doing that, you just distributed. The 3 times the x gave you 3x, and the 3 times the negative 4 gave you a negative 12, okay? So how does that look different than in algebra now that we're multiplying some polynomials? So now that we came off of chapter or unit 6 where you learned all those awesome exponent rules, those exponent rules are going to come into play because I may ask you to distribute 3x times x minus 4 now. Okay? And the most important thing to keep in mind is this little sidebar over here. So let's talk about this. And I think you have it straight by now, but in 7th grade, this is kind of the year where people kind of are confused about what x versus x, or x plus x versus x times x, and what that really means. So we know that in adding like terms, we have 1x plus another x. That means we have 2 x's, okay? But when we're multiplying an x times an x, we add the exponents, right? Remember, we keep the base and add the exponents. So knowing that we just did this in literally 6.1 and 6.2, we did it all through Unit 6, that 3x times x is just going to give me 3x squared because 1 plus 1 is 2. Okay? And then 3x times negative 4 is totally possible. You can't add unlike terms, however, you can multiply them. So that's just 12x, okay? So kind of the easiest level, one step up is then we add maybe that there. And then, so if I were to ask you to do something like this, that's a monomial times a binomial. You have not seen anything like this before. Let's take x minus 4 times an x plus 7, okay? So I'm asking you to multiply this binomial times this binomial. Now here's the thing. You just saw something like this on last section. You just got off doing x minus 4 plus x plus 7. And kind of when it's a plus, you know, the parentheses don't really need to be there. So this was just 2x plus 3, right? You combined your x's and you combined your constants. Now that there's no plus there, this problem looks almost identical. You just have to know that with nothing in between, it's asking you to multiply now, okay? So there's 2 ways to look at multiplying polynomials, and I'll kind of I'm going to show you both, and then you're going to kind of keep in mind that one way is going to be a little more helpful down the line in Unit 7. So option number 1 is to do what we're going to call a double distribute, okay? Distributing is something we are comfortable with. And so I kind of feel like most kids choose this. However, let's watch. A double distribute just kind of means, all right, let's pretend like that negative 4 wasn't there. If that was just x times x plus 7, I would just distribute the x. Sometimes people like to do and draw these little arrows there. So I'm going to multiply the x times the x to get an x squared, and then the x times the 7 to get a 7x, okay? So I just got done distributing the x. Now I'm going to pretend like the x isn't there, and I'm going to distribute the negative 4. It's a double distribute. I have to distribute twice. Negative 4 times x is negative 4x. And then a negative 4 times a positive 7 is going to give me a negative 28, okay? With binomial times binomial, it's kind of a 2-step process. So not only do you have to multiply each of these terms, you have to look at your answer and see if anything can be combined, meaning are there any like terms? And I see 2 terms that are both x's, so the terms that cannot get combined just get brought down, okay? And then your 7x and negative 4x gives you positive 3x. So when I multiplied this binomial times this binomial, my answer worked out to be a trinomial, okay? There's 3 terms. So that's the standard way to do that. I'm going to show you option number 2, and that's called the box method, okay? You will be forced to use the box method to do some work in Unit 7, Sections 5. So getting a little practice with it now is probably not a bad idea. Okay, so I'm going to do the exact same problem, and you're going to see the similarities. It's just literally just setting it up a different way. So I'm going to take my first term from my first binomial and put them here. The minus won't go in the middle. This is a -4, so this box belongs to it. And then I'm going to put the x plus 7 here. You can put a plus if you want, doesn't matter, okay? This will also work if these were flip-flopped around. These parentheses don't, the order doesn't matter because multiplication is commutative, right? So I could ask you to do x plus 7 and x minus 4, and you'd get the same answer, okay? So box method is kind of cool. It kind of works like Battleship. You know how you say A12 and you kind of follow it down? So you take this column and this row and you just multiply them and you put the product in the box. So x times 7 is 7x. -4 times x is -4x. And then your -4 times your positive 7 gives you your -28, okay? Same deal. You have to look to see if you can combine any like terms, and you can. Your like terms, if you set it up correctly, will usually be in those 2 boxes. And so you're going to have your x squared, your positive 3x, and your -28, which gets the same answer. I know a lot of kids kind of don't like making that box, but I am going to recommend that you at least try a couple on your independent practice using the box method, okay? So that's one example of something that we will see with our double distributing, okay? They do get increasingly more difficult. Like what you may see something that looks like, I may add some coefficients. 5a minus 6 times 3a minus 4, okay? I mean, not too much trickier. Same concept applies. You just have to do the math a little more advanced. So 5 times 3, we multiply our coefficients, keep the base, add the exponents. 5a times -4 is -20a. 6 times 3a is going to be -18a. And -6 times -4 is a positive 24. Our like terms, again, are our 2 middle terms. So 15a squared, same signs, add and keep. And then this is this, okay? I just want to point out something now, kind of a little bit of foreshadowing here for Unit 7.5. In our answer, in our product, because these are the factors, our last term was a product. And it's a positive because I multiplied a negative times a negative. Just something to kind of keep in mind. You'll see it later. I will show you one more way with the box method. Just kind of showing you that you would just set it up 5a minus 6 here, the 3a minus 4 here, and then you get the same answer. 5a squared. This gives you your -20a. This gives you your -18a, and there's your positive 24. Combine those terms and you get the same answer, okay? So let's talk about a couple, we call them special cases. You still just solve them the exact same way. So like if I had x minus 5 times an x plus 5, all right? So we're going to kind of try to notice something here. So if I have an x minus 5 times an x plus 5, you look at them and you think, oh, they're almost identical. Yes, except for one's a positive and one's a negative. So something special and weird is going to kind of happen here. I want you to kind of discover that with me. So x times x is going to give you your x squared. X times positive 5 is going to give you your positive 5x. Then I'm going to turn around and do a -5 times x and get a -5x. And those two are going to end up canceling, correct? But then this -5 times this positive 5 is -25. So my final answer is x squared minus 25, which looks kind of weird because in all the other problems we've done, we had an x squared term, an x term, and a constant. An a squared term, an a term, and a constant. In this particular case, it's like that middle x term canceled. So it's kind of like saying I have x squared plus 0x minus 25, which is the case, okay? But you don't write that. So this is going to be the answer that you see, okay? Let's do this. Let's say 5a minus 10 times a 5a plus 10. They look the same, just as 1 plus and 1 minus. This is going to give me 25a squared. Then I have a positive 50a, then a negative 50a, and then my negative 10 times my positive 10 is negative 100. When those cancel, I'm left with 25a squared minus 100. Okay, so now I want to kind of do a little side note here. This is going to help you a little bit later. So later, I'm going to ask you in Unit 7.5 to factor and not multiply. Multiplying is the opposite of factoring, meaning I'm going to cover this up and your problem is going to start with this, and I'm going to ask you, what did you multiply to get that? So if I say 25a squared minus 100, what two binomials did you multiply to get that? Pretending like we don't already see it right here. So you're going to say to yourself, well, this is a square number. We're going to talk about square numbers in a minute. And this is a square number. So I must have multiplied a 5a times a 5a, right? To get 100, I multiplied a 10 times a 10. And then because this is a negative 100 as a product, it has to be a positive times a negative, okay? So up here, I could have looked and said, oh, I multiplied an x times an x, a 5 times a 5, and a positive times a negative. Let's do a quick little side note with square numbers. Square numbers are 1, 4, 9, 16, 25. If I were to keep going, the next number would be 36. These are called square numbers because I got them by squaring the first set of whole numbers. So 7 squared is 49. 64, 81, 100. These numbers should be like flashing red neon signs. These are called square numbers. So when you are multiplying, like say like a 7x minus 3 times a 7x plus 3, you know that this problem is going to work out to be one of those special ones where the middle term cancels. So you know that it's 7x times 7x, so you know it's going to be a 49x squared. You don't even need to distribute. A negative 3 times a positive 3 is a negative 9, because my two middle terms would have been a negative 21x and a positive 21x, right? So the shortcut here is when you see two binomials that are almost identical but with different signs, that's called the difference of two squares. Just go ahead and square each with a minus in the middle. Okay, so if I were to say to you 81a squared minus 36 later, hey guys, what did you multiply to get that? You multiplied a 9a times a 9a. To get 36, you multiplied a 6 times a 6. And the only way that that's a negative is a positive times a negative. Okay, that's coming later. So that's kind of a little sidebar. So that's a special case. You could also do that with the box method and see the same thing would happen. The only thing that would happen is these two would end up canceling, okay? Another thing that you may see that's kind of different, you may see like a 7a minus 4 squared, okay? So this problem is done no differently than the other problems. You just have to maybe do a little bit of rewriting. So squared means the base times itself. And if the base is 7a minus 4, then times itself just means another 7a minus 4. Okay? I know what you're thinking, though. That looks an awful lot like the problem we just did. It is not. They're not going to cancel. I want to show you what happens. You're still going to have your 49a squared. You're going to have a negative 28a. Then you're going to have another negative 28a. Normally those would cancel if there was one of each sign, but this time the parentheses are identical. They're not going to cancel. And plus your end term with a negative times a negative is going to be a positive. And then you go ahead and you combine your middle terms. So 49a squared minus 56a plus 16. Let's do another one like that. So let's just do x minus 1 squared. Okay? X minus 1 squared means x minus 1 times x minus 1, which is x squared, and then you have a minus 1x, another minus 1x, and then a plus 1. For answer of x squared minus 2x's plus 1, okay? So we are multiplying polynomials, and that's about as tricky as it's going to get. Actually, I'm sorry, I take that back. What if I were to say 5x minus 2, and I wanted you to multiply it times a trinomial? X squared minus 4x plus 1. Same process, except this time you're going to distribute the 5x to all three of them, and then the 2x to all three of them. So let's just do that. Let's take 5x squared minus, actually, I'm sorry, that's not 5x squared, because 2 plus 1, going too fast. And then this one's going to be 20x squared, and then just plus 5x. Okay? Then I still have to distribute the negative 2. Negative 2x squared plus 8x minus 2. And then I have one big, long combining like terms problem to do. Standard form of a polynomial is the highest exponent first. Combine your like terms as you go. This one and this one are like terms, so I have to combine those two. These two are like terms, so I have to combine those two. And then that's that. Okay? And then the last problem I'm going to show you would be if I had like 4a minus 3b and 2a plus 7b. So the last problem is I add a coefficient here. Okay? So let's see how that pans out. Same process. Do everything the same. 8a squared. So 7a times 4a times 7b, you can multiply on like terms. 4 times 7 is just 28, and a times b is just ab. Okay? Negative 3b times 2a, commutative property says let's put that in alphabetical order, and the order doesn't matter. And then look what happens on the end, though. I have a negative 3b times a positive 7b, which is a negative 21b squared. And then when I go to combine my like terms, which are normally your two middle terms, you have your 8a squared, a positive 28ab, take 6 ab's away, and you still have 22 positive ab's. That's it. That's all that does, and that changes, okay?